In this video, we're going to examine the techniques involved in taking a multi-body part file and turning it into an assembly with new IPTs generated from those different solid bodies inside of the originating multi-body file. Now, the first thing you should consider when you look at this technique is what really will become a new part file. So here I have the make components IPT from our working files directory. And some components here, I want to just be another occurrence. I don't want them to be a separate IPT. Because if I generate these, I'll have two identical files that really should be two occurrences inside of an assembly, and I have to track them differently. As an example, I'm going to go to my solid body tree in the left-hand side and turn off solid 11, which is the lid for this little box. On the inside, I find a divider. As you can tell, I did not duplicate that divider to the second groove. Instead, I just kept it alone by itself. Because when I get to the assembly, I'm simply going to place in another divider, either through a rectangular pattern in the assembly, or by simply placing another one in and constraining it to the second groove. That way, I have a quantity 2 in my bill of material of that divider. Another thing to be aware of as you're going through and generating these part files from your new solids is that the information enclosed in those solids, such as hole information, may not carry through because we're using a derived part functionality to generate these new IPTs. So if you placed in a hole for connection purposes here, it would be difficult to carry through that threaded information into the subsequent parts. So I generally try to keep all my fastening methods, my holes, and anything that I might use to do interconnection between the components. I might save those for later to be done as individual part modeling features in the new IPTs when they are generated. However, that's also not to say that we couldn't push down parameter-based information from this model so that my location inside of the individual parts is easier to identify and link back into this original. As an example, as you recall from previous videos involving this particular design, we had parameters. If I go up to my FX button, I could simply add locational parameters for certain fastening methods as user parameters, and then this information can be carried down into the subsequent IPT files that will be generated. I'm going to choose Done here. Now, the next thing to consider is to make my solid bodies a little bit more descriptive. On the left-hand side, you can see I have already named a few of my solid bodies. And I'm doing that because when I generate the IPT files, it picks up the name from my tree here as the default naming scheme. So solid 11 was my lid. So I'm going to do a soft double click on there and call it the lid. Now solid 12 is the top heart. Solid 13 is my bottom heart. And solid 14, now that is my divider, but I'm going to show you how you can change that inside of the command that we're going to go through later on. So I'm just going to leave that one solid 14 for right now. I will turn the lid back on. There we go. As a reminder, when we go through this next process of using the make components command, we're going to see that it goes through a similar dialog box that you might see with a derived component, because that's exactly what we're doing. We're taking each one of these solid bodies and we're deriving them into their own IPT files. So what goes along with that is material properties do not carry. Color properties can carry if you choose them to. Parameters can go through a derived process. Perhaps one of the most common things that people ask for is the materials to carry through, and that just doesn't happen. So a lot of people don't really assign materials or colors like I did here in the master file. They usually just wait until they get down into the assembly and the individual parts. So to begin this process of this generation of the solids into individual IPTs, we're going to go up to our Manage tab, and we will find on the Layout panel the Make Components command. Now when you start that tool, a box will pop open asking you to select from your browser what solid bodies you would like to have included in this assembly. Now I could go through here and graphically click them as well. However, that sometimes is difficult if it's obscured by another part. So here I'll just go through and select all of these in the left-hand side. Now this will go into a new target assembly. I can specify the name of that assembly. Here it's the makecomponents.iam. I can choose a template to pull from, and also a location for this to go into. So I'm going to save this into my working files directory, and I'm going to put it in our correct chapter. This is currently chapter 6. Definitely make sure you double check that with your working files. You could also click on your folder icon here, and you could tell it to go out and find the correct folder. And as you can see, it's going to create it into a new target assembly. So that's fine. I'm going to go to chapter 6. There's my make components IAM. Just making sure it picks up the name correctly. If I didn't have the space in there or not, that might be an issue. I'm going to choose Next to move through the dialog. And now I have the ability to rename my solid bodies, as well as choose a template for each individual one, a bill of material structure, and if I choose to, a different file location. So let's kind of walk through this here on the left-hand side first. Let's start with component name. As you can see, I did not name solid 14 the divider. So now I could come in here and do this. I find it easier to perform this operation before you ever get here though. Next, you can specify a template to pull from. If the one you want is not listed here, you can click on this button that's at the top of that column to go out to your template selection window, choose a more appropriate one. We can also adjust our BOM structure. For instance, if we're making a reference component or a phantom subassembly or a purchased item, we can change that selection here. Down at the bottom, we can adjust a scale factor, also perform a mirroring operation. And really, these carry through from the derive part command. I don't use these a lot here because generally I build it the way I want to inside of that multi-body file. I can also click on Include Parameters to tell it to push down my modeling user parameters into the subsequent parts. That way I can reference the value, and if it updates from the original, I can then have that value update inside the subsequent part. As an example given before, if I had a locational control in my master assembly, I can have that carried down into the parts so that I can update one value and have both subsequent parts that reference it automatically update. Here I'll choose OK. Now the next step here is either hit the OK or the Apply button. If I hit OK, it's going to close out the dialog box and take care of business. If I click Apply, it's going to keep me in here at the same time as performing the operation. Now, in this particular sense, I don't need to hit Apply. I'd rather see OK and see it go through its business. So I'll choose that option. Selecting OK will now generate the new assembly file, close out my dialog box, and take me directly into that assembly. Now, if this looks just like the multi-body part file, graphically it should, because it referenced everything that was inside there and brought it into the assembly. It also created individual IPTs that we see here on the left-hand side. Now, as I look through here, they're all named exactly the way I'd expect them to be. If I expand them down, we're noticing that there are no constraints. They are simply grounded. Now, they are grounded based on the origin of their files. Because they all share the same origin, there is zero constraints needed for this design. I'll just collapse these. To take a look at how this is linked into here, if I change from the assembly view to the modeling view and expand one of my components, such as lid, I will see that it has a link through a derive process to the makecomponents.ipt.